Welcome back everyone to the Baldur's Gate and Unity tutorial series. In this video we're going to be going over how to use our interact functionality that we made in our last video to interact with a ladder. So we're going to make duplicates of all of these animations so that we can edit them. Now everything but one are going to have these settings. The ladder down start is going to be a little different. We're going to uncheck this bake and depose on the root transform. Then we're going to go into our animator, take all of our duplicated animations here, drag them in. And I'm just going to organize these in a way that's a little bit easier to read and make it really clear the sort of logic flow. We're going to make transitions starting from the start animations going down, and then the end animations will transition back to our locomotion. Then to start the initial climb, we will be using a transition from the any state. And we'll use triggers. One we'll call climb from top, and one we'll call climb from bottom. Actually, I hate both of those names. Let's use climb down and climb up. I think that's a lot clearer, and we will make that the condition to start either our climb up or our climb down. And you should see that all the other transitions have an exit time, so they just smoothly go into each other. Make sure the one from the any state transitioning into the ladder up start or ladder down start does not have an exit time. It just jumps right in when you hit those triggers. Let's go to our ladder and let's open this script up and revamp this so that it actually does something. We're going to make a header called ladder points. We'll make a serialized field. And for some reason my IntelliSense is not working really well right now. We'll make this one a transform for the bottom entry point and a transform for the top entry point. We'll make another new header. This one's going to be called movement. We'll make another serialized field. This will be a float for our move to ladder duration. We're going to smoothly move our character into the proper position so that when they start animating, they're always starting from the same spot, so it always looks good. So this is just how long that little transition into that position will take. We'll make another serialized field. This one will be an animation curve, just like we were doing in some of the other videos. We're going to do an ease in out with 0, 0 and 1, 1. We'll make another header for animation. Our first serialized field will be a string called climb up trigger, which is our climb up that we set in our animator earlier. And you probably guessed our next string is going to be the climb down trigger, which we called climb down. We'll make another serialized string. This one is for our movement float name, which, as we've been calling it, is just movement. Now back in our animator, this is just the things that we're talking about right now. So make sure that those match each other. We did serialize them, so if they don't match, you can always tweak them in the editor to make sure they're exactly right. Then we'll make a private bool for isBusy and a private int movement float hash. Then we'll make our awake method where we'll say the movement float hash is equal to our animator.string2hash movement float name. Now let's just delete this for now, and we'll make a public override bool for can interact. We're going to delete the default thing here and make that return not isBusy. Now let's actually make our override void for interact. We're going to say if isBusy return. Then we're going to say player move equals interactor.getComponentInParent player move. Then we'll do ground detection, and we'll say ground detection equals interactor.getComponent ground detection. If player move is null, then we're going to first do a debug log with a warning, and we're going to use a little $sign here so that we can expose some variables. We'll say climb ladder, no ground detection found on interactor, and then we'll say in brackets interactor.name or its parents. So whatever the interactor is, we'll get the name of it and it'll be really clear what we're dealing with. And then we'll return. If we don't return, then we're going to say transform player transform equals player move.transform. Then we'll say transform chosen point equals get closest entry point, which will take player transform as an argument. We're going to make that closest entry point in a moment here. If our chosen point is null, then again, we'll first do a debug log warning. And we'll say climb ladder, no valid entry point assigned. And then we'll return. Again, if we move on, we'll say bool from bottom equals chosen point equals bottom entry point. We'll say start coroutine, move player, and begin climb. And this coroutine is going to take player move, ground detection, chosen point, and from bottom as arguments. And we'll make that in just a moment. But first, let's make that private transform get closest entry point. This is just to help us so that if we're at the bottom of the ladder, we know that's the set of animations that we want to start. And so we're determining which end of the ladder we're on by having these invisible points that the player will detect and say, hey, you're closer to the bottom of the ladder, we need to be starting our upwards climb, and so on. We'll use these if statements to determine which one is closer, and then we're going to say float distance to bottom equals vector3.distance, player transform.position, and our bottom entry point.position. Then we'll have another float, you guessed it, distance to top, where we'll say vector3.distance, player transform.position, top entry point.position. And then we will return the distance to bottom less than or equal to distance to top, question mark, bottom entry point, colon, top entry point. Now let's make that I enumerator. We're calling this our move player and begin climb, which takes player move, ground detection, transform, we're going to call this our target point, and a bool from bottom. Now we're going to say is busy is true. And we actually need to go back into our player move script and add some things here. So first we're going to make a new serialized field under our movement header. This one's going to be a float called 0 snap threshold. And we're going to set that for a very, very small number. This is not a requirement, but I'll explain why it's necessary later. We're going to make a private bool called allow root motion and set that to true. And then we're going to make a public animator, and we'll have a way to access this animator. And then we'll have a private climb ladder, which we'll call active ladder. Now let's pop down to the bottom of this script here, and we're going to update our onAnimator move method. We're going to say if we're not allowing root motion or our animator is null, return. If we are, then we're going to say vector3 delta position equals animator.delta position. We're going to say quaternion delta rotation equals animator.delta rotation. Scroll down a bit here and we'll say if ground detection does not equal null, then vector3 horizontal delta equals delta position and horizontal delta dot y equals 0. And we'll go down and say if horizontal delta dot square magnitude is greater than our very, very small fraction here, then we're going to say vector3 move direction equals horizontal delta dot normalized. Then we'll say if our ground detection can move in a direction, and that's false, delta position dot x equals 0 and delta position dot z equals 0. Then we're going to say public void set movement input enabled. It's going to take a bool, we'll call it enabled. Then we'll say can move input equals enabled. And we'll say rotation velocity equals 0. Then we'll say debug.log, use our little $sign so that we can say player move on and then insert the name. Set movement input enabled, enabled. That should make it really clear what we're looking at. Then we're going to say if can move input is false and our animator does not equal null, then animator.setFloat movement parameter hash, set that to 0. Then we'll scroll down, make a new public void, call this set root motion enabled with another bool that's called enabled, and we'll say allow root motion equals enabled. And again, we'll just debug this and say player move on name set root motion enabled, enabled. And you have to use brackets or that's just going to literally say enabled. Then we'll say public void set control state, another bool, this one will be movement input enabled, and it will take another bool for root motion enabled. We can say set movement input enabled, set root motion enabled, root motion enabled. Then we'll make another public void. This is going to be called anim event enable movement. So basically when we run our ladder logic, we're going to stop the player from being able to move during that motion. And when that's done, we need to go and set in our animation this method to trigger when the animation is done so that the player can go back to being able to actually move themselves. We'll make one more public void. This one will be set active ladder, which will take a climb ladder as an argument. We'll say active ladder equals ladder. And I lied, we actually need to make one more public void. This is going to say notify ladder that the climb is finished, as we wrote above in our animation event. We're going to say if active ladder does not equal null, then active ladder dot finish climb game object. Active ladder equals null. Now we're going to make that finish climb method in our climb ladder script. Now let's go back into our coroutine and we'll say animator equals player move dot animator. Transform player transform equals player move dot transform. If our animator is null, Then we're going to make a debug log warning and say, hey, climb ladder, player move has no animator assigned. Then we'll say is busy is false, and we will break the coroutine. Then, assuming we move forward, we'll say debug.log, climb ladder, using player root, and we will put player transform.name so that we see that, and go animator, animator.name. Now we're going to say player move.set active ladder this. Then we're going to say player move.set control state to be false, false. Ground detection.set gravity enabled to be false. Ground detection.set obstacle detection enabled to be false. We'll say vector3 start position equals player transform.position, and quaternion start rotation equals player transform.rotation. We'll drop down and say vector3 end position is our target point dot position. Our quaternion end rotation, you guessed it, target point dot rotation. Then we're going to make an elapsed time here. It's just a float that will start at 0 so that we can track the passage of time. We'll say while elapsed is less than our move to ladder duration, elapsed plus equals time dot delta time. It's basically just a timer that's running. We say float t equals mathf.clamp01, elapsed divided by move to ladder duration. Another float called curved t will say move curve.evaluate t. Then we'll say player transform.position equals vector3.lerp, start position, end position, curved t. And I accidentally put a space here. I need to say vector3.lerp. Why is this not working? Okay, sometimes this happens when you auto-fill things. This system.numeric was causing a conflict, so I just need to delete that, and now it's all working again. Player transform.rotation equals quaternion.slurp, not lerp, start rotation, end rotation, curved t. Then we'll say yield return null. Then after that is over, we'll say player transform.position equals end position, and player transform.rotation equals end rotation. Then we'll say animator.float, movement float hash 0f, animator.reset trigger, and we will insert the climb up trigger, and animator.reset trigger, and the climb down trigger. Then we'll say yield return null. Then we'll move on and say player move.set control state false true. Then we'll say string trigger to use, and we're going to say from bottom question mark climb up trigger colon climb down trigger. Then we will say animator.set trigger to be our trigger to use. Then we'll say debug.log and just make it really clear to ourselves here which animation was triggered and on what animator it was triggered. Now let's go down here and make a public void. Like we said earlier, we need to make our finish climb method. It's going to take a game object, which we'll call interactor, player move equals interactor dot get component in parent player move. Then we'll say if player move is not null, player move dot set control state to be true, true. And we'll say is busy is false. And we need to go back into our player move and add this little thing into our update method that says if movement value is less than 0 snap threshold, set our movement value to be 0. So all this is doing is making it so that when the game runs, I've just noticed in the animator, if you're watching the little movement parameter that we have, as we try to move around, sometimes you'll see values when we're not really moving that are like, 1e to the negative a bajillion, and I got a little tired of seeing that. So this just makes it so that it will say 0 if it's anywhere that close to 0. Now I'm just going to show you, I've created this top entry point and bottom entry point, and here are my exact values if you would like to copy these and get it just the way that I have. You need to make sure you drag those in and make sure these names all line up with the names in the animator. The ladder's exact transform here, you can copy mine if you'd like. Same with the platform. This is just a cube that I scaled up and positioned in this exact spot. Now we need to go into these animations and actually assign the animation event. So you pull up the animation tab, go to the end of the animation, and if it looks like this, make sure you've actually clicked on the player, and then in the animation tab you have to select the animation. Create an animation event, go into here, go into methods, click on that animation event method that we made earlier. It's the exact same one for both the top and the bottom ending animations. Now we should be able to jump into play and everything should work. And look at that. When you press spacebar, you smoothly move to the spot and the root motion animations look really good. You very precisely go up and down the wall, you end up on the ground. That's looking really solid. We can climb up. It's amazing. Now this doesn't really look like Baldur's Gate for a number of reasons, one of which is our camera. It's not by default looking top down. We have no ability to manipulate it. In the next video, we are going to start going over our camera settings and our logic to control it. So look forward to that one, and I'll see you guys next time.